Hi everyone, welcome to another Galaxy for Bioinformatics tutorial session. In today's video, I'm going to show you how to run circles on Galaxy to visualize genome assembly coverage. So this is what we are going to generate by the end of this video. Alright, this is a plot we'll generate. So this is a plot of genome assembly coverage. So the outer circle, the one with the different colors, is an ideogram, right? Or ideogram, right? And it's used to depict context, that is in the context of this tutorial. Okay, so in the context of this tutorial, the ideogram is representing context. All right, and I also have the labels for the context. So I have 1 to 50. The inner circle, this one here, the orange one, it's used to represent the coverage. Or let me just put it this way: the number of reads that's mapped to each of the contexts. Right, so that's what we are going to do. So I am going to briefly explain how I got the input data for Circos, how I got the input data, and then generate the plot out of it. So I'll switch to the data source. So first of all, I got the FASTQ files for a Markov Ostrans isolate. So I'm dealing with paired and width. I performed my Genome assembly using spades, and I got my contigs, which are all in this file. And then I map the reads back to the contigs, and I generated a BAM file. This is the BAM file. And then what I did was to look at the contigs, look at their respective lengths, and pick the top 50 longest contigs. And then I extracted their mapping information from the BAM file, i.e., the number of reads that's mapped to those contigs, the top 50. And then I use that to generate this input, coverage.txt, this file here. And then I generated a Circos plots. Okay, so this is the data, the histogram data, right? So I'll show you where to get all the input files, so don't worry. So let's do this. I want us to first visit the Galaxy platform and then proceed. So there's the page. I'll leave the link to this page in the description box. So I'm using the galaxy.eu server, but you can also use the .org. I'll leave all those links in the description box, so any of them is fine. And I also advise you to create an account and log in. That will enable you to save the session, okay, when you exit the browser. It's important to do that. So what I'll do first is to create a history. So I'll come to the right side, click on plus, and then I'll get this unnamed history, and then I'll come to edit. I'll edit, and I'm going to rename it. So I'll just say Circos assembly coverage, and I'm going to save it. Perfect. So now I'm ready. So what I'm going to do next is to generate the ideogram. All right, that's what I'm going to generate. So of course we are going to use some input file, and so you will need to import that data. So let's move to this GitHub repo of mine. I'll leave the link to this page in the description box. I repeat, I'll leave the link to this page in the description box. So when we are here, I want you to download or import, because we're on Galaxy, I want you to import this file, karyotype.txt. So to import, click it, and when you click it, you'll be sent to this page. And when you're here, come to the right side and click on raw. So click on raw. When you click on raw, you'll be sent to this page. So when you're here, I want you to copy this link, copy it, and then move to Galaxy. When you are here, come to the left side, click on upload data. So click it, and then when you are here, come to paste/fetch data. So click paste/fetch data. Then in this box, paste the link. After pasting, click on start, and then make sure that the status here is 100% and an output has been generated. So now you can close it and you can monitor this file. So at the moment it's great. That means that the job is queued. And so what you have to do is to wait for the background to turn green. So once it turns green, that means that the file has been successfully imported. So let's wait for the file to be imported. Okay, the file has been imported, the character. So what we are going to do is to generate the ideogram. So let's come to the left side where we see tools. This box here, so tools. So click it and then type Circos. After typing Circos, you should see some list coming up. Select this one. Circos visualizes data in a circle layer. That's what we need. So click it and the tool will be opened. So when you are here, I want you to come to reference genome source where you see Circos presets. Click and then select custom karyotype because we have our own karyotype file. So click custom karyotype. Scroll down to karyotype configuration. You are going to see the karyotype.txt file shown. If you don't see it, click on this browse datasets and select it, or click this one and select it. Now let's go down to ideogram, this side here. So click it, scroll down to spacing between ideograms in chromosome units. So here I want you to use 0.0, or you can just say 0. Right? We don't want any space between ideograms. So that's what we have. And then I want you to scroll down. Everything here, we will leave it as it is. Let's scroll down to labels. So click labels, scroll down, show label should be yes. Radius, change it to 0.03. So 0.03. This one worked for me, so I prefer to use that one. Label font size, let's make it 40. Para, make sure it's yes. So that is it. Okay, so that's all that we need to do to generate the ideogram. So now I want you to click run tool. So click it, the tool is going to be run. So you are going to see an output called Circos plots. So what you have to do is to wait for the file to be processed. And then if everything is okay, the background will turn green. And when it turns green, then we can explore that file. So let's wait for the file to be processed for us. Okay, the plot has been generated, so we can look at it. So I want you to come here, Circos plots, click it, and then save it. So save it. I'll save it here. That is it. So I'm now going to explore it. So I'll open the folder which has the file, and there it is. So I'll open it to see what is there. Okay, so this is what we have. Okay, so everything has been done nicely for us. So this is how we generate the ideogram, okay, in Circos. All right. Take note that because we are using Galaxy, we don't have to code. All right. So if we were to code, then you have to open something like this. Okay. So I have some content here. So this one, I use it in my previous tutorial where I showed how to run Galaxy on the terminal. Okay, so if you've not watched that and you want to watch it, just check the description box, the download link is there. Okay, so you would have entered some commands like this and then run it. But in Galaxy, you don't have to do that. You just do click, add, drop, grab, etc. So Galaxy makes things convenient for you if you are not into programming. So that's it. Okay. So let me just open again. So this is how we run Circos on Galaxy to generate an ideogram. So everything is looking good. So the ideogram here, generating it is also a form of test. So once we do it and everything is okay, we save the settings and you can now add on, right? So that's what you need to know. Okay, so let's proceed. Let's get back to Galaxy and continue. Okay, so now we know that the character file is okay, ideogram settings is fine, and so we will need to generate the plots, the main plots. Let's get back to our presentation. So we are now going to generate this plot here. Okay, so that's what we will do next. So let's get back and then let's proceed. Okay, so now we are going to generate the genome assembly coverage itself proper. Let me just show again. We are now going to generate the genome assembly coverage. So we will generate our ideogram and then our histogram plots at the same time. Okay, so this is what we are going to do. We are going to import all the files again. So what we are going to do is that we are going to create a new history first. And then we are going to edit it unnamed. I'll edit it, I'll say Circos Genome Assembly Coverage visualization. And then I'm going to import the files again. So let's get back to the GitHub repo. I'll just start from here, main page here. The link to this page is an exclamation box. I repeat, the link to this GitHub repo is an exclamation box. So we are going to import coverage.txt and then character.txt. So let's start with coverage. So click it. And when you click it, you'll be sent to this page. Come to raw, click on raw. And when you click on raw, I want you to copy this link. So right click and copy it. Copy the link and move to Galaxy. When you are here, come to the left side and then click and paste slash fetch data. Click on this one, then paste the link. Okay. And then you can now click on start. Make sure start is 100% and output has been deleted. So you can now close it and wait for the background to turn green. That means that the file has been processed. In the meantime, I'm going to correct this one. So this typo, I'll correct it. It's a name, by the way, so you can choose to give it any of your choice. So with the naming, I leave it up to you. You know what you want to use there. So I'll leave that to you. So you have to just make sure that you have an appropriate name. So I'll save and then make sure the name is as I want it to be. So now let's wait for the file to be imported. So while the file is being processed, it's also advisable that we import the other file, the character. So let's get back to GitHub. Let's get back to the main page and then let's click on character.txt. So the same procedure. So click, come to raw, click on raw, and the link, copy it, move to Galaxy, click on upload data, come to paste slash fetch data, and then come to this entry box, paste, and then click on start, this one here. Okay, so click it, when you click it, make sure status is 100%, and then the outputs generated, then you can close this. And then you have to wait for that to also be processed. So now we have 2 files in process. So all of them, their respective backgrounds return green. So let's wait for that to be done and continue. Okay, the files have been imported, so we can now proceed. So we will import them. So again, let's come to the search tools section. I'll just restart. So on the left side where you see tools, click on search tools, type Circos. And then you have a list coming up. You will need this one, Circos, visualizes data in a separate layer. That's what we need. So click it, and then you will have this coming up. So we will start with the character. All right, so come to reference genome source. Here it says Circos presets. Click, and then select custom character. And then move to character configuration. You see character.txt. Okay. If you don't see it, click and select it. Then when you are here, if you don't see it still, click on browse data sets and select it. Okay, but it should be fine. Scroll down to ideogram. So we are using basically the same settings we did previously because that one worked. So click on ideogram, scroll down to spacing between ideograms. Okay, change it to 0. Okay, and then scroll down to labels like this one here. So click on labels, make sure show label is yes. Radius you use 0.03. Okay, and then come to label font size, make it 40, and then make sure power is yes. And then that is it for the ideogram. Now we need to add the histogram plots. Okay, that's for the coverage. We need to add that. Okay, so we are using histogram. And by the way, if you want to read more about histogram, come to this Circos page here. I will need to show you that before we proceed. So you can read about Circos histograms here. Okay, let's get back. So we are going to add the coverage information. So we will need a 2D data track. So come to this side. So click 2D data tracks, scroll down, and then you see this insert 2D plots, 2D data plots. All right. So click on the insert 2D data plots, and then you see something like this coming up. So here it says outside radius, I'll use 0.85. Inside radius, I'll use 0.6. Then I'll scroll down to plot type. I'll select histogram. If you don't see histogram, click and select histogram. And then when you come to histogram data source, you may not see the data or the files. So what you have to do is to select. So come to this side. If this one is unresponsive or is not enabled, come to browse dataset. Click on browse dataset and select coverage.txt. Okay, let me just go over. So click on browse dataset and select coverage.txt. You may see this text unavailable, but it's fine. So far as the file name has been indicated, it's fine. So now you can scroll down to plot format specific options. All right, so click it, and then here we have fill color. Choose any color of your choice. I will choose orange or something like that, this one. But you can use any color, that's fine. At this point in time, it's up to you. You decide what color you want. So click to select, and then that is it. So that is all that you need to do, and it's okay. Okay. So once you are done with it, then you can proceed. Please note that you can still do some further processing, but we will do that later on. That's for advanced users. For now, I'm dealing with beginners, so I'm doing a basic plot. But there are things you can also do, such as changing colors, adding rules and stuff. But that's for another day. All right. So for now, let's click on run to, and then wait for the plots to be generated for us. Okay, the plot has been generated, so we can look at it. So let's download it. So I'll click, and then I'm going to save it. So I'll save it, and then I'm going to view it. All right, so I'll just open it here. Okay, so this is it. So I'll open it for us to see. Nice. Now the plot has been generated. So we can see our ideogram. We can also see the coverage plot. Okay, so that's how we generate a coverage plot for genome assembly data using Circos, all right, on Galaxy. Please take note that on Galaxy, you don't need to have any programming experience, all right? So if we were to run this on the command line, then you need to, for example, have commands like this that will be used to specify options and then configurations for the plot. But in Galaxy, all of these things are done behind the scenes, all right? So all I have to do is just click, add, drop, drag, etc. Okay, so that's how we do it. Okay, but if you have lots of data sets, then it's advisable to use the command line version to do it. Okay, now for those who don't know, this same tutorial I've made one where I showed how to run Circos on a command line and then use all these commands in the same plot. So if you're interested in that, you can just check the description box for that video. And also with the histogram, this strategy can also be used, for example, in gene expression analysis. For example, you have done a gene expression analysis, you want to visualize the counts, maybe the number of counts, or let me just put it this, so the number of differentially expressed genes across the chromosomes. You want to count them. You can use a similar approach to visualize, and that will also give you a good plot for you to start with. All right, so Circos, when you generate plots like this, it also gives you a compact visualization. Okay, so I have come to enjoy it, and I'm going to be using it more. So if you also have challenges with running Circos or setting it up, you can also reach out to me and then we can work out something out. The key thing is about you getting the information in the proper format like this, okay? And this requires some form of manual work and some form of scripting. If you have R or Python or any programming language, you can just use that to extract the information. All right, so the information here is not straightforward. You have to extract it and then compute it in the way that you want and use it. So that is where it's important to consult an expert to help you do that. Of course, you can also reach out to me if you want something like that, and we can look at how best to do it. Okay, so this is how we run Circos on Galaxy to generate a genome assembly coverage, and I will see you in the next session.